Welcome, welcome. Today we're going to be completing a Unit 6 review on proportional and linear relationships. So hopefully this will help give you a nice little overview of everything we learned in this unit and get you ready to take your test. We're going to start off with reviewing proportions. Remember, a proportion is when you have two ratios typically expressed as a fraction and they are set equal to each other. You could have a proportion where the two ratios are written as, with a semicolon. I just often like to write them as a fraction because I think that's a little bit easier to see and work with. So when you have a proportion, which we have here, we have one ratio, 4/3 is equal to the other, 8/x. One way that you can solve this is using cross multiplication. So we can multiply the numbers that are across from each other. So first we'll do 3 times 8. And then that is set equal to you multiplying the other way across. So 4 times x. And now we just need to solve this equation for x, and it will give us that missing value. So we can divide both sides by 4, and 24 divided by 4 is 6, giving us a value of 6 for x. Now, when we move into proportional relationships, they still have that proportional equality there, but we have several choices here, and we want to know which of these equations would represent a proportional relationship. Remember, in order for something to be a proportional equation, it must be in this format, where K is our constant of proportionality. So if we look through our answer choices here, this first one is a proportional relationship. Y is equal to 8x. The second one is not, because this -4 at the end takes away that equivalency factor. It takes away that proportional connection. And then on the second one, we have the third one, we have an exponent. That makes it not proportional as well. But then our fourth one here would also work because it's just 9x. So the first and the fourth one are both answers that represent a proportional relationship that match that requirement equation format. All right, let's continue to move through what we learned. And now we're to constant of proportionality, which I had talked about in equation format in that last question. But here we're given a table, and we want to first off determine what the constant of proportionality is, and then express our answer as an equation. So remember, when we're dealing with proportional relationships, because that was one part of our unit, to find if they have a true constant of proportionality, there needs to be that proportional relationship between your x and your y values. So you can simply take your y value and divide it by your x value and see if all of those end up being equal, if it is proportional. So here we can take 76 and divide that by 4, which is 19. And then if we come over here, we can do 57 divided by 3, because remember, we do y over x. We need to do it the same each time. And we also get 19. I always, when I'm given a table, if I'm, asked to find that, I like to check multiple ones just to make sure, especially if it's, on an assignment and I don't have, a time limit or anything. So for the next one here, 190 divided by 10 would be 19. And then 133 divided by 7 is also 19. And last but not least, 171 divided by 9 is 19. So they're all the same, which does help us confirm this is a proportional relationship. And we found that our constant of proportionality is 19. To write our equation, that is y is equal to kx. And remember, k is what we use to represent your constant of proportionality. We can just substitute that in and we'll have our equation. The y is equal to 19x. And there we have our answer written as an equation. Let's compare proportional relationships. Let's read our first scenario here. So the graph represents the rate at which Marlowe makes origami birds for a craft fair. The equation y equals 2.5x represents the number of birds y that Josh makes in x minutes. Who makes birds at a faster rate? Well, whenever we're comparing, the best way to compare is to find that constant of proportionality for each, and then we can see, in this case, who makes birds at a faster rate. Well, let's go ahead and start with Josh here. We have an equation given for Josh's scenario. So we know that for Josh, he can make 2.5 birds every minute, because that's our constant of proportionality. So that's what Josh's is. For Marlowe, we have a graph, so we are going to need to calculate it. So in this case, our graph is on the x-axis, which is horizontal down below. It's skipping lines. So it really is counting by tens. So always be careful of that. And then here on the y-axis, it didn't skip any lines, so it truly is counting by 2. So just like with our table on the previous question, to find that constant of proportionality, we need to take our y value and divide it by our x. So if we look at our first point here on the graph, that first time it crosses perfectly, you can put a point there. We have 2 birds, and it takes 10 minutes. Well, because Josh's information is as a decimal, let's divide that fraction out to also give us a decimal, because that'll make it easier to compare. So for Marlowe, if we take 2 and divide that by 10, we get 0.2. So Marlowe, it takes a little bit longer because Marlowe can't even get 1 bird done in a minute, where Josh is obviously Speedy Petey over here because he can get 2.5 done. So Josh is our winner. He can make these birds at a much faster rate than Marlowe can. All right, we're going to transition into our linear equations here. And remember, linear equations do encompass proportional relationships. It's kind of like that saying where all squares are rectangles, but not all rectangles are squares. All proportional relationships are linear, but not all linear relationships are proportional. If that didn't make sense to you, that's okay. But in this question, we want to find that slope of a line. And when you're given 2 points, as we have here, and we want to find that slope, we want to find that rate at which the line is either increasing or decreasing, there's 2 main ways of doing this. One is to use the slope formula, and that's pictured here in the upper right-hand corner. Or you can put it into a table of values. Honestly, it's personal preference. I'm going to do a table, and really the only reason I do a table is what I've found is with the slope formula, there's a higher chance of getting your numbers backwards or confusing and mixing up your subtractions and your negatives. It's not the case all the time, but I've, seen that a lot as a teacher. And so I've kind of started using the table a little bit more often because I think that way of organizing just decreases some of those silly little mistakes. So we can just create a simple t table or a simple t chart, which is, you just your x and your y values. So first we have 19 and negative 16, and then we have negative 7 and negative 15. And to find that slope of the line, it's very similar to a proportional relationship, only with slope, we want to discover how much our y is changing by. That's what that triangle for delta means. And then we want to know how much our x is changing by. So it's still y over x, but we need to calculate that change. The way that you calculate how something changes in math is through subtraction. If we want to know how much you have grown, how much you've changed over time, you would subtract your two different heights to find that change, to find that growth. Same goes here. So we're going to start with our y value. It doesn't matter the order as long as it's the same. So I'm just going to go top to bottom. We're going to take negative 16 and subtract from that our negative 15. Always make sure you write it out when negatives are involved. This will help limit mistakes. So we have negative 16 minus a negative 15. First thing I notice, I hope you guys caught this too, is we have this minus a negative. Remember, whenever we have minus a negative, they cancel each other out and it really becomes a plus sign. So negative 16 plus 15 would be negative 1. And if we look at that, it kind of makes sense. If we picture a number line in our head, if we're going from negative 16 to negative 15, that's only changing by one space. Now we'll do the same for our change in x. We got to make sure we go in that same order. So we'll take 19 minus a negative 7. Ooh, looky there, it happened again. We have minus and negative, those cancel each other out and it becomes a positive. So we simply have 19 plus 7, which would be 26. So our change in x is 26. Once again, it kind of makes sense that it would be a large number because if we picture that number line, if we're going from that 19 all the way to the negative 7, that's going to be changing quite a bit. When you look at your final answer for your slope, see if you can simplify your fraction at all. In this case, I can't, so that actually would be our final answer. The slope of our line is negative 1/26. Now we want to find the slope of a line from a graph. Sometimes when you're given a graph, we've specifically put points on there for you just to make sure it's a little bit easier to read, or maybe, draw your attention to those certain points. But other times you're just given a straight line. But remember, that straight line is made up of a whole bunch of points. We just want to choose the best ones. Because technically speaking, let me get my little laser here. There is a point right here on our line. But that's not really the best one to choose because that's between different grid lines. So I'd have to estimate, and what I think the value is might be a little different from you. So whenever you're given a blank line and you need to add points to it to answer a question, I always pick spots where your line intercepts, where your line crosses both the X and the Y, so both of your grid lines perfectly, because I know that's an exact value and it's going to be a lot easier to work with. So I'm going to put a point here, and then it looks like I got to go all the way down to here for another point. So those are the 2 points that we're going to use to find our slope of a line. Because if you're finding the slope, if you're finding the change, you need 2 different values to see how it's changing. So when we have a graph, it is technically still change in y over change in x, but you may also have heard it referred to as we are finding our rise over run. So if we just go from left to right, because that's how we read most books, and we start at this lower point, we would rise 1, 2, 3, 4 spaces. And since there are no numbers on the graph, that means it's counting by ones. So that's how I knew to just count up by ones. And then we're going to go from that point and we're going to run over, or go from that spot and run over. And we're going to run 1, 2, 3. So 4/3 is our slope. Remember with slope, as long as we don't have a word problem or anything like that, we want to have our answer as either a fraction, not a mixed number or anything, a fraction, or a whole number. So we're going to keep our answer as this improper fraction, and the slope would be 4/3. All right, let's write an equation for this line. And our focus for this semester, and this year in fact, is writing equations in slope-intercept form. So slope-intercept form is y equals mx plus b where m is our movement, that's our slope, and then the b is the beginning, that's your y-intercept. It doesn't really matter which value you find first. I'm going to find the y-intercept first just because it's so quick and easy. Here we have our y-axis. We're just looking for that point at which our line intercepts, at which our line crosses through the y-axis, and that would be right here. So we know that we're going to have a y-intercept of 2. And then in this case, even though we're not numbering all of our labels, I can see that it is counting by ones. It maybe used skip counting when it did the labels, but the graph itself is still counting by ones. Well, I have 1 point down. So now let's pick a second point here so we can calculate our slope. Remember, look for that closest grid line, and this is the closest one I see. You can choose any point on there, but the closer they are together, the less likely it is that you would need to simplify your fraction. So it kind of, saves you some time. Well, let's find our change in y over our change in x, our rise over run, and we go up 1 over 2. So up 1 over 2, meaning we have a slope of 1/2. So when we put that together as our equation in slope-intercept form, our answer is y equals 1/2 x plus 2. I think these right here are my favorite type of questions when we interpret them, because it kind of helps bring the real world in, even if we don't always make graphs to represent these real world situations. It does make that connection. I just love it. So here we see that Tara pays a base rate for her long distance phone service plan plus a per minute charge. The graph shows what she would pay for her long distance phone service for the first 60 minutes. What does the slope of this line represent in the situation? In this case, we're specifically being asked, what does the slope mean? What does the slope represent? Well, before we can even figure out what it means, we need to identify the slope. So again, I'm going to choose 2 points that intersect grid lines so I don't have to do any estimating. And I would see there's a spot here and a spot right here. All right, let's check and see what we're counting by. I can see that for my change in y, my rise, it looks like I'm counting by 2s for every grid line. So that means I technically go up 2. And then for my change in x, I can see that we're counting by 10s. That means I go over 10, 20, 30, 40. And we do want to simplify this fraction. So that would simplify to be 1 over 20. All right, cool beans. We know what the slope is, but we need to know what it represents. The easiest way to identify what it represents is honestly to look at your labels, and then we can kind of piece that together with our story. So our Y value is 1, and the Y label is cost in dollars. So that means that 1 is $1. And then our X, which is 20, is our time in minutes, meaning this is 20 minutes. So this slope represents that Tara here is going to have to pay $1 for every 20 minutes of using this long distance phone. That is that rate. That is that additional charge there. And that answers our question. I'm not going to type it out since I said it on the screen, but that's what this slope represents, is that for every dollar, or you probably would more say it like this, for every 20 minutes that Tara is on that phone, she's going to be charged $1. All right, final question here is we are now going to graph this equation. And this equation that we're given here is both proportional and linear. So we can kind of look at this, in both ways when it comes to graphing. It's a perfect example. So when we have a proportional relationship, that is, one of the things, that's what happens when our B value, because remember, if it's linear, Y equals mx plus B, is equal to 0 when there is no additional change. It's just straight up your constant of proportionality, your slope. It's that constant rate. It's not going to be changed or affected by that B, by that starting value. Meaning our graph is going to start right here at the origin. That's our y-intercept for all proportional relationships. Next up, we need to graph our constant of proportionality, also known as our slope, which is 6. But remember, when it comes to graphing, we always need that to be written as a fraction so we can get our y over x, so we can have our rise over run. So you can rewrite any whole number as a fraction by just putting it over 1. So if we want to write this out our different ways, we have y, which is our rise of 6, over our x, which is our run of 1. So that's how we're going to move to get our second point. So we start here at our y-intercept. We start here at the origin in this case, and we're going to rise 6. 1, 2, 3, 4, 5, 6. And then we're going to run 1, and that is where we will put our second point. And if you wanted to get a third point, you could, but technically only 2 are required. Remember that whenever you're doing these slopes, if you want to get that other point and you've run out of room, you can do the opposite. So we can do -6 over -1. We can go in the opposite direction. So down 6 and left 1. And that will give us, if Mrs. Ailstock could draw a straight line, it would give us a nice straight line. I'm just, not very good at that without a ruler. But we have now graphed our linear equation. All right, that is it for our review. So it is now your turn to go ahead and check out the note page that accompanies this video, or go ahead and take your test. If you have any questions, feel free to come to a help session or reach out via email. But good luck, guys. I know you got this. Bye.